Hello guys, in this video we are given a question which reads, prove a theorem that states the opposite angles of a cyclic quadrilateral are supplementary. This is opposite interior. So opposite interior angles of a cyclic quadrilateral are supplementary. Like angle C and angle E, they must add up to 180 degrees, or angle D and angle F, they also need to add up to 180 degrees. So our required proof is C plus E is equal to 108. So we need to do these two. So for us to prove that, we need to do some construction of line that is from D to A. A is our center, then F to A. So I'm going to construct it in dotted lines like that. Our center now is now divided into two angles, which is this angle and the inner one. So this one I'll mark it A1 and this one I'll mark it A2. From the theorem which states that angles at the center are twice angle at the circumference. So angle A1 is equal to 2 times angle C, which is the angle at the circumference. So I'm going to mark it 2C like this. Then this one, A2, is angle at the center and the angle at the circumference is E. So A2 is equal to 2 times angle E. But angle A1 and A2, they are angles at a point that is going to form a revolution, and it adds up to 360 degrees. Let me add the reasons for this one. For the first one, A1 and A2, the theorem that we use is that angle at center is equal to 2 times angle at the circumference. Same with this one, we apply the same theorem. So we are saying A1 plus A2 add up to 360 degrees. This is because there are angles at a point there is a revolution. But we have defined that our A1 is 2C plus A2 is 2E. This is equal to 360 degrees. Then we can factorize 2 here. Then we'll be left with C plus E inside the bracket. This is equal to 360 degrees. Then we divide by 2 both sides. So we'll be left with C plus E is equal to 360 divided by 2, which is 180 degrees. Then we have proved C plus E is 180.